Good afternoon, everybody. Welcome to another of our series of talks as part of our Ice Worlds exhibition. My name's Ed. Oh, good, we're excited already. That's good. We want to keep that kind of enthusiasm. My name's Ed. Strangely, I'm an astronomer, but I'm going to be your host. You don't have to pay attention to me for much longer, don't worry. I'm just going to do just a little bit of housekeeping. I mean, first of all, if you haven't already seen them or you want to see them again, then the exhibition's up on the Great Map, and there's a couple on this floor as well. I really do encourage you to go and look at some of this stuff. It's very, very cool indeed, but it's on a sort of slightly different if you like, ticketing system. You know, there's so many people enthusiastic about this. We want to make sure we keep control of capacity. So if you don't have a ticket already, then please speak to a member of staff and we'll try and get that sorted out. I can't promise anything, but we just need to sort of filter you through properly. I hope that makes sense. But let's not worry about that for the moment. I am going to introduce our speaker, and I'm going to just see if I can... Please do correct me if I'm getting any of this wrong.
Right.
Dr. Alex Brearley is an oceanographer, a Natural Environment Research Council researcher with the British Antarctic Survey.
Hang on.
So hopefully that all makes sense.
Yeah.
And is interested, amongst other things, in physical oceanography. And I've got to say, has an incredibly interesting, it sort of draws people in. Our title for the talk is Cool Robotics for Oceanography. So I think, without further ado, I'm going to hand over to you, Alex.
Right, thanks, Ed, and welcome everyone, and thank you so much for coming today. First of all, has everyone seen the new ship? Has everyone been down to the harbour side and seen the new ship? Yeah. So everyone's seen our state-of-the-art new research vessel. So obviously, it's in Greenwich Harbour today, but the conditions that it's more likely to be in is something like this. So the polar oceans, where it goes, tend to be very rough, lots of big storms. So it needs to be really well equipped to deal with those kind of problems. But also, it's not just a ship, it's also a platform for lots and lots of cool, cutting-edge new technology. And that's what I'm really going to be talking to you about today. I'm going to be talking about robotics, what we use those for, and some of the insights it's giving us into our polar oceans. Oops, sorry, that's me going down. Okay, so first of all, for our younger members of the audience, what do they think oceanography is? Any suggestions? Yep. Yep, taking pictures of the ocean. Yep, that's one thing. Anyone else? Yep.
Finding out about the ocean.
Yeah. Studying the ocean. Yeah. So all of those different things are true. So the honest answer is there's lots of different types of oceanography. Okay. And I'll show some of them up here. So there's physical oceanography. That's what I do. So I study ocean currents. I study how the ocean takes up heat. I study how the ocean takes up carbon out of the atmosphere. There's chemical oceanography, so that's thinking about many of the nutrients that are in the ocean that fertilize the marine ecosystems. And that obviously feeds into the biological side, both the very small scale things like phytoplankton, right up to your big charismatic megafauna like penguins and whales. And then there's even geological as well, so people who go down and study the ocean, the geology of the ocean floor. Okay, so they drill into the ocean floor, understand the sediments that are down there, the rocks that are down there. So when we're thinking about marine robotics, we're thinking about robots that do all of these different types of things. And I'm going to primarily talk about the physical ones today, but there's also, as I say, a whole bunch of other things. And there's a whole bunch of great talks this week about all these different types of oceanography. So another one for the younger members of our audience. How much of the Earth do they think is covered by the ocean? There's one very, very enthusiastic gentleman here. Yes? 70%. Oh, you're doing pretty well. Pretty much bang on. It's 71%. So yeah. So really, when we talk about the Earth, we should really be thinking about it being called water, because most of it actually is water. Only about 29% of it is land. And the Southern Ocean, which is the place that I study, so that's the bit right at the bottom of the Earth. So what we're doing here is we're looking down on the bottom of the Earth here. So you can't even see Britain on this. There's Australia there, there's Africa here, there's South America down here. That connects all those different ocean basins together, the Indian, the Atlantic, and the Pacific. Okay, so it's a really important place for the global ocean circulation. It's a place where strong winds can blow all the way around the planet. So if you think about it, you've got these strong westerly winds in the mid-latitudes. They blow all the way around the planet in this region. And that has important effects on the oceanography. It means it's a really important place for the uptake of heat and carbon dioxide into the ocean. But it also creates some very, very big storms, as you're about to see. So this was some video taken by a colleague of mine called Eleanor Fryker-Williams at the National Oceanography Centre. And you're going to see what it's like to be in a Southern Ocean storm. So I'm just going to play this. This is taken from the bridge of our current research ship. So bear in mind, this is probably sort of 20 to 30 meters off the ocean surface here. So that they're standing right at the top here. Okay. Yeah. So it's fierce, okay? It can be really, really fierce. And so in order to be able to observe those kind of places, you have to have an array of different types of technology, okay, to do that. The ship itself is not enough, okay? So increasingly, we're turning to robotic autonomous technology in order to be able to observe these wild and wonderful places. The other key thing is that because it is so stormy, it's generally very, very poorly observed. Okay? So we've got Britain up here, and this is just a heat map showing the track of commercial and research vessels over a one-year period. I think this was from 2015. Okay, and what it shows is that while the shipping lanes of the North Atlantic, the North Pacific, from South Africa across the Indian Ocean are quite well observed by measurements, there's actually very, very few of them in the Southern Ocean. There's these whole white deserts where there's just a complete lack of data. Okay, so if you look all the way down here, there's basically no measurements done across large swathes of the Pacific, Indian, and Atlantic Oceans over that one-year period. Okay, so we have to have technologies that will fill in these data gaps because we know about the centrality of the Southern Ocean for controlling our climate. So another one for the younger members in the room. How would you go about taking your temperature? Anyone know what we'd use to temperature? Yes? What are we talking about? That's a very good question. We're talking about how would you go about taking your temperature? So if you were poorly, how would you go about taking your temperature? Oh, I think we've got an enthusiastic member here. Using a thermometer, exactly. So and it's exactly the same principle happens in the ocean. Okay, so apart from in the ocean, this thing is about 6 foot across and goes all the way down into the far, far deeps of the ocean. Okay, so this is what we call a CTD, and it measures the temperature and salinity of the ocean and allows us to collect water samples right from the surface all the way down to the bottom of the ocean. And how deep do people think the ocean actually is in the deep ocean? Any ideas? Yep.
10,000 meters.
That's not a bad guess. It's not a bad guess. Most of the ocean's about 5,000 or 6,000 meters deep. Okay. The Marianas Trench, you're right. The Marianas Trench is nearly 11,500. So yeah, very good, very good. So we need instruments that can go down and have large pressure casings to be able to withstand that kind of atmospheric pressure. Okay, and so this is something that we would take over the side of the ship, but we increasingly rely on robotic observations as well to do this. So we obviously have ships, and that's our previous research ship. That's the James Clark Ross that the new ship is replacing. But we also employ increasingly this suite of new autonomous vehicles. So down here at the bottom, we've got what's called an underwater glider. That's a small, low-powered vehicle. It can go for many months in the ocean, taking measurements of temperature, salinity, a whole bunch of biological variables. You'll see this on the right here. This is what's known as boat face, which there's a model of in the museum. So that shows you that's effectively a more capable version, shorter range but more capable version of that that you're seeing on the right there. But we also use a whole suite of other things. So we can measure, for example, the skin temperature of the ocean from large satellites. We use long strings of instruments that are deployed on moorings to monitor ocean currents, for example. So we use this whole suite of different vehicles, and increasingly the ship that we have is really a platform for many of these different types of ocean technologies. So a couple of examples. First of all, this is Boating at Boatface. It's actually its actual technical name is known as AutoSub Long Range, and what this is it's a propelled underwater vehicle. And increasingly, we're using this kind of tech to get into very remote places in the ocean. So one of the most remote places this has been is under large ice shelves around Antarctica. So ice shelves are these huge tongues of floating ice that come out from the continent. There's something, almost all the world's frozen fresh water is kept frozen up in Antarctica. And that discharges in large glaciers. And those glaciers actually form floating tongues of ice that cover the ocean for several hundred miles out to sea. And we can use these platforms like Boating at Boatface to get into those cavities. And they're really important from a scientific perspective, because if we're going to make really good predictions about how much sea level rise is going to happen in the future, we need to be able to get into those cavities to make those measurements in those most remote places. So that's what we're using this kind of technology for. So this particular mission, this is a project that was a collaboration between the University of Southampton, ourselves at BAS, and the National Oceanography Centre. This was actually sent down to explore one of the big submarine canyons in the Southern Ocean. So our polar oceans are places where we get the formation at the surface of really dense waters. Those really dense waters fill up the bottoms of the ocean, the abyss, effectively, of the ocean. And even if you go down, even if you're in the tropical oceans, if you go right down to the bottom of the tropical ocean, you'll find cold water that ultimately came from the poles. And so what this project was doing was to try and understand the pathways of that cold water in these constricted canyons in the southern part of the Atlantic. So there is an animation with this. So this just shows an animation of what Boaty was doing in this particular time. And you'll see that it basically traverses along the side of this canyon. And the little things it's dropping are just showing effectively the temperature that it's taking. And it's really helping to map out the pathways of these dense water plumes that are coming out of Antarctica. And we know these plumes are really important. We know they're important in those processes of carbon dioxide uptake from the atmosphere and draw down into the deep ocean. That's important because we know that the ocean is a key repository for carbon dioxide in the atmosphere. So something like 30% of all the CO2 that's been put into the atmosphere since the start of the Industrial Revolution has actually ended up in the ocean. So the climate situation we're in at the moment would actually be far worse were it not for the role of the ocean. And a lot of the uncertainty around future climate change is actually driven by the fact that we don't know how well the ocean is going to carry on doing that into the future. So understanding these pathways of deep waters that draw much of this carbon into the deep ocean is really key. And so using these kind of technologies is a really important way of understanding that. As I say, the other ones, of course, is the other use for AutoSub Long Range has been to try and get under these big chunks of frozen ice. So this is a project called the FIS project that was run from BAS. And so, when we try to look in these cavities that are under these ice shelves, we can use a number of different tools. So I've got colleagues at BAS who will camp out on these big these big ice shelves, and we'll drill through hundreds of meters of ice to get into this ocean cavity underneath, okay, and put moorings there, put measurements there that will take measurements of the temperature and currents in that water column for up to 10 years at a time. Another way of getting in there is with autonomy, with autonomous vehicles, and Boaty and others are really cool ways of doing that. So the new ship really will be a a much more purpose-built, equipped platform for understanding these kind of processes and allowing us to deploy a range of different autonomous vehicles at any one time. It's not just about the ship and the labs themselves, impressive though they are. It's about doing all of these things together. This was a project I was involved in, so I led this. So another really important question is the degree to which ice around Antarctica is melting from the ocean versus from the atmosphere. Okay, so in much of the world, we think about the warming atmosphere, and we think about that melting ice. But actually, what we know has been happening around the Southern Ocean is that that big band of winds that I was talking about earlier, we know that those have been increasing. It's been getting more stormy. And what that's doing is changing through a whole bunch of different physical processes, that's changing the amount of warmer water that's intruding on the shelves around the Antarctic. Now, when I'm talking about warmer water here, I'm not talking about bath water. I'm not talking about 20-degree water. I'm talking about water that's maybe 1 or 2 degrees above freezing, as opposed to 1 or 2 degrees below freezing. Okay? But the crucial factor there is that it's warm enough to melt ice. Okay? It's warm enough to melt land-based ice coming off the continent. And so we deployed a whole bunch of these small robots around the West Antarctic to try and understand some of those processes. So these are small buoyancy-driven vehicles. We can deploy these for many months at a time. They go from the surface down to about 1,000 meters deep, so they cover pretty much the continental shelves of the ocean. And every time they come back to the surface, they transmit their data, and they say, here I am, where do you want me to go next? Okay, so they're pilotable. And these are really cool, because these you can actually pilot from your phone. Okay, so they're not just, it's not just it's not just command files. This is really kind of cool tech. So yeah, I had these out for 2 or 3 months for this proposal. We're gradually increasing the endurance of these. We've got a project for these going out for 10 months this year. So the pace of tech is changing quickly. And they measure a whole bunch of things, so temperature, salinity, and pressure for the physical side, chlorophyll, backscatter, oxygen, turbulence on the biological side. So this was my team. I'm on the back right there. This was a very collaborative effort, actually, between myself, National Oceanography Centre in Southampton, the University of Gothenburg, and a bunch of others. And we actually deployed a suite of these different vehicles. So, and then at the back, we've got what's called a surface vehicle. Okay? So increasingly, as well as the underwater robots that we're using these vehicles that measure the conditions right at the very surface of the ocean. Because the conditions at the very surface, you saw those big storms at the start, those big storm events are really responsible for fluxing a lot of the heat and a lot of the carbon dioxide across the ocean surface. So if we're going to understand how the Southern Ocean is important going off into the future, we need to be able to understand all those different parts of the system. Okay, so this was a project, we had these out for about 3 months in the region between South America and Antarctica, a place called Drake Passage, which many of you will see on the map upstairs later. So I'm going to leave it at that. Please do come and see us on the Marine Robotics stand. We're all very friendly. So I work with my colleague Hugh here. Leo has just submitted his PhD, so well done to him. And then we've also got Rachel, who's a postdoc at Bass, and Peter, who's joining us from the University of East Anglia as well. So the stand is up by the Great Map. Please come and say hi. And I am happy to take any questions. And you can also, as I say, see a glider and another smaller autonomous vehicle up there. So thank you very much.
Thank you very much, Alex. That was absolutely amazing. Folks, we've got a little bit of time to do a bit of a Q&A. So what's going to happen is I'm going to come and I'm going to repeat your questions, which sounds a bit odd, but we've got people tuning in on YouTube, and so we want to make sure they hear everything as well. So I'm going to listen, repeat, and then we'll test Alex with as many questions as we can. So let's. You had your hand straight up. What do you want to ask? I'm not entirely sure. You want to see the gigantic round part.
Oh, is it
the map?
Maybe you want to see the map? Hold on.
You just want to see it again.
Oh, which one? Sorry. This one? Yeah. Do we deploy the? Is the question? Do we deploy the robots from the boat into the water? Yeah. Okay. So we'll use our big ship to go out into the middle of the Southern Ocean and deploy our vehicles. Some of the vehicles we can actually deploy from shore. Okay. So the surface vehicles that I was talking about at the end, actually we can actually propel many of those from the shoreline. So that one I showed in the final slide, the surface vehicle there, was actually recovered in the Falkland Islands. So we piloted it about 500 miles at the end of its mission back into the Falklands, and it was picked up by a small boat in a bay. So we don't necessarily need a very large research ship to deploy some of these vehicles. It kind of depends on the size of the vehicle, though. Obviously, Boating Boatface is pretty big, so you need something fairly substantial. But the gliders, I mean, I've done it in a small rib, so a small inflatable in a bay off Antarctica, just literally trolley in and, it's gone. So, yeah.
Okay, we'll take some from, we'll go to the middle here.
Why did you decide to conduct your oceanography experiments in Antarctica?
Why do I decide to conduct oceanography experiments in Antarctica? That's a very good question, because all of our oceans are, as you know, all of our oceans are important places. The polar oceans, so the...
Sorry, Alex,
yeah.
Can I get you to come slightly this way?
Sorry,
We'd love everybody...
Am I disappearing away? Yeah, no, that's fine.
Well, thanks.
So the polar oceans are really important places in our climate system. They're really the linchpin of the whole, the center of the whole ocean circulation. And the reason for that is because they are the place where surface waters of the ocean, so waters that are in the top couple of hundred meters of the ocean, get made dense by cooling at the surface and by a process which we call brine rejection, which is effectively, as sea ice forms, you get salt ejected into the water. That cooling process and that salinification process, those two things together make those waters really dense. And it means that those waters sink down to the bottom of the ocean. What that can do with it is it can take that CO2 out of the atmosphere, and that then locks up there for hundreds of years, okay? So it means that the ocean effectively acts as like a buffer on the atmosphere, okay? So the reason it's so important that we go to the Antarctic, and we go to Greenland as well, in the Arctic, is because that is one of the key places of transformation, I guess, in the ocean system. So, yeah, no problem.
Go to this young lady here.
How heavy is Boating Boatface? It's a few hundred kilograms, so it's probably about the weight of five or six humans. So it's fairly substantial. It's about 500 or 600 kilos. Yeah.
Okay. Anyone else?
How often do you go out on the boat?
How often do I go out on the boat? Okay, so I would typically go out for 1 to 2 months per year. Okay, so most of the time my job is an office job in Cambridge, where I will analyze data that I've collected at sea and use that to write scientific papers, to understand the oceans. But I will spend typically a month or two per year on the ship. I haven't done any fieldwork for the last 2 years because of COVID, but typically I would go out for about that amount of time. We do have crew, of course, on the ship, and the crew on the ship will be there for many months at a time, taking lots of different science parties to do their research. But yeah, myself as a researcher, 1 to 2 months a year generally.
Okay, we've got time for a few more. This young man's had his hand up.
What sort of machine is the fastest?
Which of the robots is the fastest? Was that the question? Yeah, that's a really good one. So the really fast ones generally, I mean, Boaty is reasonably fast, but the fastest ones generally are the surface vehicles. So the wave glider that I showed you towards the end, some of those can do 2, 3, 4, 5 knots. Okay, so they are quite, sorry, what a knot is a nautical mile per hour. So they can travel almost like little ships, effectively. The really slow one is the underwater glider. Okay, so that one I was showing in my project. They only do about very slow walking pace. Okay, now that may sound a bit boring, but actually it's really important because that very slow pace means that they have very low battery consumption. Okay, so they can put them out for many, many months at a time. I say up to 6, 8, 10 months at a time without having to recover them. So really it's about the choice of robot you use is really about the science question that you're asking. If you're choosing something that has a time scale of a week or two or a few weeks, then one of the big vehicles is obviously very capable. If you want something that's much more long-term, then the much more efficient vehicles tend to be the way to go.
Okay, we've got time for a few more. I'm just wondering, give me a second, I'll come round to you. I want to make sure we get everybody, but also can get people in the middle of the rows. Okay, on you go. Is it scary on the boat?
Is it scary on the boat? No, I can't say I've ever been scared. I mean, I have had colleagues who've been in bigger seas than me who have been scared. We will tend to try and avoid the stormiest seas. The biggest seas I've ever been in, I think the biggest wave was about 15 meters. So what's that? In old money, that's about 50 feet. So it's the height of a 3-story block of houses, something like that. They are very, very capable ships. I mean, you certainly get thrown around. The plates will start flying off the shelves, and everything has to be nice and securely strapped down. But I don't think I've ever been in the stage where I've been scared. You kind of get through an excitement phase. You mainly just get fed up with not being able to sleep. You kind of wedge yourself in a bed, and your stomach turns, and then your stomach turns, and then you're like, oh my goodness. And after 3 sleepless nights, it starts getting a bit wearing. Yeah.
Can I just follow up on that?
Yeah.
I was going to ask you maybe not so much scary, but in a more general sense, what's it like to be on board a ship where, if you're so far south, obviously the seasonal changes are quite extreme there. So, what's a day like when you have maybe huge amounts of daylight, for example, and short nights?
Yeah, that's right. So, obviously, we will tend to go to sea in the summer. So, generally, for the summer being south, that's between kind of December and February. So, I'm actually going to sea in about 4 weeks' time. Yeah, I mean, once you get south of 66 or 66 and a half, you have periods where there is no nighttime in the summertime, and then in the wintertime there will be no daylight. Okay, so, and the honest answer is it's a bit disorientating to be in 24 hours of daylight. Okay, so you can very easily, be sitting down in the evening, reading a book or doing something, and you suddenly find it's 2 o'clock in the morning. And your body has not got that natural connection to know that it's nighttime. So it's a very kind of weird place to be. The flip side, of course, is that in the wintertime, when, I'm not generally there in the winter, but our colleagues who are there on the base in winter, there's a period of, a month or two where there's really no daylight at all. So they're in constant darkness. So I guess they have the same kind of issue, but it's just never light. And the problem, that period of permanent light or permanent darkness gets longer as you go nearer and nearer the pole. So if you're at 66, it's not a particularly long period of the year where it's 24 hours of daylight. But if you go to the bottom of the Weddell Sea or to Svalbard in the far north where it's 80 degrees north, for example, then you've got many months where it's constant daylight. So yeah, it's disorientating.
Right. Well, I think we've got time for one last question. This young man seemed very keen. What's the ship called?
So the ship's called the RRS Sir David Attenborough, named after our very famous naturalist who kindly agreed to give his name to the ship. And yeah, we all think an incredibly worthy. The ship is an incredibly. We're very honoured to have Sir David give his name to the ship, and we hope that it will carry on much of the legacy that he's he's done in the public sphere, in the science sphere. So.
Right. Well, folks, we would ask questions all day, I'm sure, but I'm afraid to say we're out of time. This is just one of a series of talks that we're doing, not just today, but over the course of the next couple of days as well. So please do check them out. Please come back. If you want to dress like a penguin and take part in the penguin parade, it does make sense. But if you want to do that, then please speak to a member of staff.
I'm sure you'll be doing that, won't you?
Oh, yes. So there's all sorts of stuff going on. As Alex has said, please come up and see the robotics part of the robotics exhibit, which is part of the much larger exhibit. There's all sorts of stuff going on up there. So if you haven't checked it out already, then please do. If you've got photos or cool things and you want to interact with us, then at RM Greenwich, we've got all sorts of things going on, and I think hashtag #IceWorld links you to absolutely everything. So, first of all, can we say thank you once again to Alex for this wonderful talk.
Thank you.
Very much.
And I'll be hanging around for a few minutes in case anyone was too shy to ask questions in the public session. So if people want.
Brilliant. And thank you, everybody, for coming. And at that, we have to shoo you out, I'm afraid, because we've got other things to
All right.
be doing. Bye, everyone.
Thank you. Bye-bye, everyone.